Okay, let me summarize what we have seen so far in the derivative. Okay, what we saw is if f is not continuous at a point x equals to a, then the derivative at x equals to a or f prime at a does not exist. That's one thing we saw. And if f is continuous but have sharp corner at x equals to a, then the derivative does not exist. So continuity is needed, but it should not have a sharp corner, okay, to have a derivative. All right. So if f prime of a is the slope of y equals to fx at x equals to a, so not if though, f prime of a is the slope of y equals to fx at x equals to slope of tangent, okay, slope of tangent of y equals to fx at x equals to a, because see this is y equals to fx, that blue curve, and then at x equals to a there is a tangent line I draw, that's the purple tangent line. Okay, the slope of this tangent line is basically given by the derivative of that function at a point a. And also we saw that if fx equals to x to the n, then f prime of x equals to n times x to the n minus 1. And the last but not the least is, so the if f prime of a exists, then f of x is continuous at x equals to a, but not conversely. Okay, what does that mean? That means that we saw that if a function is continuous at a point a but has a sharp corner, then the derivative does not exist at that point. But if the derivative exists though at a point, then the function is continuous by default. Okay, if the derivative exists, then the function is continuous. But if a function is continuous, that may not imply that the derivative exists because of the case of the sharp corner or the cusp, like that case. Okay, let me do very last example of this section. What it says is find the equation of tangent line to fx equals to 2x squared. So there is a curve that is fx equals 2x squared, and that curve, the tangent line is parallel to this. Okay, so the tangent line is parallel to this curve. Okay, so since the tangent line to this curve and this line are parallel, then the slope of the tangent line of this and the slope of this are equal to each other, right? So we will write the slope. But what is the slope of this curve? The slope of this curve is basically the derivative, right? How do I find the derivative? Let's find out the derivative first. So f prime of x equals to, you see that limit h tends to 0, f of x plus h minus f of x over h, right? Let me simplify that. It is 2x plus h squared minus 2x squared over h. Okay, so let me do that. Equals to limit h tends to 0, right? What is 2x plus h squared? It is 2, and then x plus h times x plus h minus x squared, 2x squared, by the way, 2x squared divided by h, right? Let us simplify that. Let's FOIL that. It is 2 times x squared plus 2x h plus h squared. After FOILing, I get that, minus 2x squared divided by h, right? So this is limit h tends to 0. You distribute that 2x squared plus 4xh plus 2h squared minus 2x squared divided by h, right? So you see that there are something you can cancel out, negative 2x squared and positive 2x squared. So what is left is 4xh plus 2h squared. Now I want to factor that out. So how do I do that is, so you can write 2h out and then x plus, you can write h, right? If you take 2h out, oh, by the way, 2x plus h, because if you take 2h out, because 4 is 2 times 2, right? 2 and h out, so 2 and x left and plus h left there, divided by h. Now if I cancel that h and h, what do I get? If I cancel those h and h, then I will get limit h tends to 0, and let's plug in that 0. So you can write 2x plus h, right? If you plug in h tends to 0, you will get 4x. So the derivative of 2x squared is 4x. Now, since the tangent, this is the slope of the tangent, right? Equals to this is the slope of tangent. Since this tangent line is parallel to this line, then the slope of this line and the slope of the tangent are equal. That is, so slope of curve equals to slope of line, right? So slope of the curve is the derivative, right? So the derivative, so it is the derivative, that is 4x equals to, what is the slope of this? You need to solve for y, right? If you add y on both sides, you'll get y equals to 2x plus 3, right? 2x plus 3. So the slope here is 2, right? Slope is 2. So what is x? X is 2 over 4. That is 0.5. That is the x. Okay. Now we need to find out the equation of the tangent line. So when x is 0.5, what will be y for this curve? Or what is the y for this curve? So y will be 2 times 0.5 square. How much is that? 2 times 0.5 times 0.5 will be 0.25, right? So 2 times 0.25, that is 0.5 again. So x is 0.5 and then y is 0.5 and y is 0.5 as well. So you want to find out the equation of the tangent line. So how do I find the equation of the tangent line? Let me do that. So it will be y minus y1 equals to m x minus x1. That is the equation of the line or tangent line, whatever. So this is x1, y1. And what is m as well? So m is the slope, right? M is the slope, 4x, right? So m is 4 times the x. So but what is x? That x is 0.5, right? 0.5 times 4. So 4 times 0.5, that is 2. So m is 2. So you can write y minus 0.5 equals to 2 times x minus 0.5. Now simplify. Y minus 0.5 equals to 2 times x is 2x, and then minus 2 times 0.5 is 1, right? Now you add 0.5 from both sides. So what do you get? You get the final answer is y, add 0.5, add 0.5. What do you get? Y equals to 2x minus 0.5. So that is the final answer for this problem.